Hello everyone, myself Sai Prasad, a lecturer in Ahilabad High School and the Junior College. Welcome to a series of the lectures of Intermediate First Year Maths B. We have started our discussion of 1B with the different geometrical chapters. From today, we are going to start a new concept, that is calculus, which includes the functioning of a particular function. Right? What do you mean by the term? I told you the term functioning. Why? From today, we are going to discuss the actual behavior. What happens? What are its limits? How it is going to continue? What happened if we differentiate it? Clear? That's what we are going to discuss. Today, we are going to start a new chapter, that is limits and continuity. The name itself, we can identify that the limit. We are going to identify the particular limits of a function, right? It doesn't mean it may be domain or range, but it is actually a kind of a same thing, right? What happens if we are going to limit a function at a particular point, right? When a function is said to be having a particular limit, right? When a function is said to be continuous, how can we define it? That's what all those things we are going to study in this chapter, okay? Shall we start? Now let's see. Before going to learn what is a limit and what is continuity, we have to know about two things, that is interval and neighborhood. You would have known about a bit introduction about interval. What is the interval? Tell me. Interval, it defines the range of values. There are two kinds of brackets which you have to remember from now. That is, for example, if I tell this square bracket and this rounded bracket or else some circular bracket, whatever you feel, I have these two types of condition. What is the difference between these two? Tell me. See here, if it is in the BODMAS or different kinds of thing, you would have used different kinds of brackets, a square bracket or curved bracket, or in the sense of those curly brackets, right? We would have used different brackets, right? Here, this indicates that this is called as closed bracket, okay? This is called as closed bracket and this is called as open bracket, or else simply a closed parenthesis and open parenthesis, right? Just tell me, what do I mean by this? This clearly means that, for example, if I tell x belongs to a comma b, what do you mean by that? It tells that x is a value which lies between a to b, right? Here also it tells that it lies between a and b. Then what is the difference between these both? That is, here it tells that x may be any value between a to b including the values of a and b, isn't it? Here it tells it includes all the values of in between a and b excluding a and b. Clear? Right? How to tell? Say here, this can be written as x may be less than or equal to b and greater than or equal to a. Clear? Here it tells that it lies between x and b. It doesn't mean they are equal to a and b. Clear? Is it okay till here? Fine. And the next thing, that is neighborhood. What is this neighborhood? See here, it is very clear that neighborhood is some kind of value which is at a plus or minus value. Okay? It tells it has a range of a plus or minus. For example, if I have a range of some a to a, for example, if I have some value of a, then when it can have a neighborhood, that is, if it we vaguely tell that it lies between a minus delta to a plus delta, where delta is called as neighborhood, okay, which means a lies between a minus delta to a plus delta. This is the symbol of delta, okay, you can remember that. This is also delta, the triangle is also delta, don't get confused. Here this is the delta which is used in our mathematics, which is simply called as neighborhood. Clear? Which means if this a lies between this a minus delta to a plus delta. See here, for example, if this a and b are some values, okay, which means this a and b are the values which are at a finite distance which from a particular value, let us say some c. If I want to get a value of c, that c minus delta, c plus delta are nothing but this a and b values. Is it clear? Which means if they are at a finite equal distance, then we can call it as a neighborhood. Clear? That's what the simple difference. Then what is the limit? What is the importance of limit? Shall we look into the definition? Let's see. Here limit, it defines that if f is a function which it defines from E to R, some domain E to a real numbers ka R, and there is some value A belongs to R, right? Let us assume some value such that A minus R plus A plus R excluding the value of A, that is the domain or the interval A minus R to A plus R. For example, if there is some particular A which includes minus infinity to A and infinity to, A to infinity excluding A intersection E, which means if there is any common term in E. Is it clear? Once again let me tell, whatever value A which belongs to in the range side and excluding A, whatever the value it is before A and after A, okay, the neighborhood set, if that is similar to A, which means it should not be an empty set, okay. If it is not an empty set, for every R greater than 0, R should be obviously positive. Then there exists a real number L such that mod f of x minus L is always less than epsilon whenever x belongs to E, okay. Here x is some particular value of f of x, then f of x is always equal to L, which means it clearly tells that it is said that the limit of function as x tends to A exists and it is nothing but L. Clear? Once again let me tell, whatever the function, some domain to range, okay, if that is given and it has a neighborhood of R, right, is it clear? There is some value A which has a neighborhood of R and the values of that are included in E, that is in the domain. Clear? If that set is some number, then whatever the number, there exists a real number L such that f of x is always equal to L, or simply f of x minus L always lies within the limit such that x belongs to E, then it is said to have a limit, and we can simply define it as limit f of x as x tends to 0 is equal to L. Once again let me tell, this is defined as limit x tends to 0 f of x is equal to L, right. In most of the places they write it as LT, even that is also okay, okay. Limit x tends to 0 f of x is equal to x, okay. This L is nothing but my limit value. Clear? Fine. Based on that, let's have a few simplification kind of thing. For example, if I have two functions f of x and g of x and their limits at x tends to A are L and M, okay. What if I add those both functions? I will get L plus or minus M. If I add, I will get L plus M. If I subtract, I will get L minus M, okay. If I multiply, I can write separately. I can write it as limit x tends to f of x into limit x tends to g of x, or else if I multiply the whole function with a particular constant, then I can remove the constant and write it as it is, okay. From here we are going to define a few things where a constant I is to be kept outside and everything you have to remember, and if it is in the denominator, I can go and write in the denominator. If they are in the division, I can directly divide the functions, I can directly divide the limits. Clear? Shall we do few problems? See here, once again let me tell, limits is again one of the most kind of easy chapter, but only thing is we have to learn few things. When the limit value has to be substituted, when it cannot be substituted, what is the case where we can simplify, okay. In order to know that, we have to know one basic thing, that whenever we substitute this value, we should get an answer limit some L. This L should not be in a undeterminate form. What is this undeterminate form? That is, the output or the limit should not be in the form of 0 by 0 or infinity by 0, infinity by infinity, right, or something this kind of thing. These are always called as undeterminate form because we don't know what is 0 by infinity. Do you know? We don't know, right? That's what. And not only that, infinity by 0 we can't assure, or infinity by infinity. Infinity itself is an undefined value. What can we define its division? Isn't it clear? And not only that, just remember you can get the value of answer as 0, you can get the value of answer such as infinity, but we can't define when infinity is divided by 0, infinity by infinity kind of thing, we can't define it. That's why make sure that whatever you get the answer, it should not be in undeterminate form. Clear? Shall we do few problems? Let's start. Once again, I am reminding the answer should not be in undeterminate form. Okay? Now let's see the different questions. See here, whatever he tells, he always tells you to find either compute or evaluate. Okay? Look at the first question. Limit x tends to 1, x square plus 2x plus 3. Right? Check whether if you substitute 1, is there any chance of getting 0 by 0 or infinity by infinity? However, there is only numerator. There is no chance of getting denominator, right? So, let us directly substitute the value in it. What will be the solution here? Solution is, that is 1 square plus 2 into 1 plus 3. That's it. 1 square is 1, 2 into 1 is 2 plus 3. 1 plus 2 is 3, 3 plus 3 is 6. This is the answer. Clear? Once again, let me tell you, it should not be an indeterminate form. Did you get an indeterminate form? We got a real value, right? Fine. Let us take it to the next question. Here, the question itself given as x tends to a. What if I directly substitute a? Just check it. A minus a, 0. Denominator will be 0. Numerator a square minus a square. Again it will be 0. 0 by 0 will be an indeterminate form. Then what to do? Clear? If there is an indeterminate form, you have to remember that we have to simplify a bit. How to simplify and what to simplify. Clear? Now just check it here. X square minus a square. Can I do something with that? Tell me. X square minus a square can be written as x minus a into x plus a. Isn't it? Fine. Let us write it as limit x tends to a. Here x minus a into x plus a divided by x minus a. Now tell me, can I cancel these both? We can write, fine. This will be limit x tends to a, nothing but x plus a. Now just tell me, if I substitute the value of a instead of x, what it will be? Will it not be direct answer? Yes, it is, right. Therefore, here instead of x, if I substitute it as a, this will become 2a. That is my answer. Is it clear? What did we do? First, we have to check whether this will be an indeterminate form or not. If yes, go for the simplification step. Okay? Yes, how did we simplify? Here x square minus a square can be written as x minus a into x plus a. So that this x minus a will get cancelled. I will be left with x plus a. Is it right? Now let us check with the same with the next problem. What is the question given here? Limit x tends to 2, x minus 2 by x cube minus 8. Let us check it randomly. 2 minus 2, 0, numerator is denominator. If denominator is not 0, then it's fine. We can directly write it as 0. But before writing it directly, we have to check whether denominator is also 0 or not. Just check it here. 2 cube minus 8. What is the value of 2 cube? That is 8, right? 8 minus 8, again 0. The denominator is becoming it as 0. Again it is also 0 by 0, which is indeterminate form, right? So in order to avoid that, we have to simplify this in different way. How to do? Just tell me. Yeah, 8 can be written as 2 cube. Okay. Now let's see here. Limit x tends to 2, x minus 2 by x cube minus 8 is 2 cube. Do you know the formula of x cube minus a cube? Right? A cube minus b cube, that is only. That is nothing but, let's write x minus 2 by a cube minus b cube formula is a minus b into a square plus b square plus ab. Is that right? Once again, let me tell you, limit x tends to 2 and numerator is x minus 2, denominator is a cube minus b cube form, which is a minus b into a square plus b square plus ab. Done. Now just check it here. X minus 2 will get cancelled again. We can directly substitute the value of 2 here. Isn't it? What is left? Here limit 1 by x square plus 4 plus 2x as x tends to 2 is left. Just check, is there any chance of getting 0? No, right? 2 square plus 4 into, right? Directly substitute it. This will become 2 square plus 4 plus 2 into 2, that is 1 by 4 plus 4 plus 4, which is 1 by 12. Isn't it? Is it not the answer? What is the similarity between the before sum and this sum? The only thing is this, here it is in the numerator, here in the denominator. Here we have used x square minus a square, here we have used x cube minus a cube formula. Okay, fine. And the next question, what to do with this? Just check whether we are getting 0 somewhere. If I substitute 2 here, 2 plus 1, 3, 2 by 3. Here if I substitute 2, directly I will get the value. There is no problem of thinking. 2 plus 1 minus 3 by 2. Therefore, answer is 2 by 3 minus 3 by 2, which is LCM is 6, 4 minus 9, that is minus 5 by 6. Is it done? Is it clear? Fine. Very good. Let us move on to the next question. Just tell me, if I substitute the value of 3 here, what happens? Here 3 square, 9, 9 plus 15, okay, that is 24. Substitute the value of 3 here, 8 3s are 24, 24 minus 24, numerator is becoming 0. Let us check for denominator, 3. 3 square, 9, 9 minus 9 again 0, 0 by 0, which is an indeterminate form. Therefore, we have to simplify this. Yes, we know here I can write 9 as 3 square, x square minus 3 square. I can write it as x minus 3 into x plus 3. Then what about numerator? X square minus 8x plus 15. How to simplify? Tell me, what are its factors? We can factorize it, right? 15 factors, 5 3s are minus 5 minus 3. Therefore, numerator can be written as x minus 3, x minus 5. Clear? Shall we do this separately? Let us take only this term. Let us check what it will become. That is x square, 15 factors, minus 5x minus 3x divided by here x square minus 3 square. From these two terms, I can take x minus x common and I will left with x minus 5. Here if I take 3 common, that will be x minus 5. Denominator x minus 3 into x plus 3. Let us take x minus 5 common. What will be left? X minus 3 by x minus 3 into x plus 3. X minus 3 get cancelled. What is left? That is x minus 5 by x plus 3. Is there any chance of getting 0 there? If I substitute 3 here, 3 minus 5 minus 2, 3 plus 3 is however 6. Let us substitute it. Therefore, limit x tends to 3, x minus 5 by x plus 3, that is equal to 3 minus 5 by 3 plus 3, that is minus 2 by 6, which is minus 1 by 3. Is it right? Did you understand? What is the difference between these sums and these two sums? That is, only the numerator was different, either numerator or in the denominator. Here we have the problem with both the numerator and the denominator. We have simplified the numerator and also the denominator. We found the factors for the numerator and the denominator. Is it clear? Did you understand? Shall we move on to the next problems? Let's do. Now the next question, that is, he is asking us to compute the value of x square sine 1 by x. How to do? Just tell me, if I substitute 0 here, 1 by 0 is infinity. Do you have any value of sine infinity? We don't have, right? Then how to do? Is there any way of simplification? Just check here, 0 square, that is 0. 0 into something? Obviously 0. Okay? Directly you can substitute it here. That is, just separate the limit. Limit x tends to 0 x square into limit x tends to 0 sine 1 by x. Okay? That is, as x tends to 0, this will become 0 square. Here, let us put it like this only, sine 1 by x. 0 square is 0. 0 into something, what is it? Whether it is infinity also, 0 is something is always a 0. This is very important 2 marks question. But the thing, the logic you have to remember is this is 0 term. Therefore, obviously the other terms also become 0. Okay. Then look at the next problem. That is here again 3 square minus 9. Again 9 minus 9. Here 27 minus 6 into 9. Okay, let us check here. 27 plus 27, 54. Here 6 into 9 is again 54. 54 minus 54, again numerator also becoming 0. 0 by 0, again it is an indeterminate form, right? That's what. Then how to simplify? The only way is factorization. Here that everything is in cube, square and 9x. Can I take x common here? Yes, right. Let us directly first simplify this. That is x cube minus 6x square plus 9x by x square minus 9. How do we simplify the first step? Let us take x common in the numerator. It becomes x square minus 6x plus 9. In the denominator, x square minus 3 square. Okay. Now tell me x square minus 6x plus 9. That is nothing but x minus 3 whole square. Or else if you are willing to factorize, we can. What are the factors of 9? 3 3s are minus 3 minus 3. X square minus 3x plus 9 divided by x square minus 3 square. Okay. Then what is left? X into, if I take x common, I will be left with x minus 3. If I take 3 common, I will be left with x minus 3 divided by x square minus 3 square. That is equal to x minus 3 will be common. Here one more x minus 3 will be common. In the denominator, x square minus 3 square, I can write it as x minus 3 into x plus 3. Here x minus 3 get cancelled. What is left finally? It is x into x minus 3 by x plus 3. Okay. The next step, let us apply limit. Limit x tends to 3, x into x minus 3 by x plus 3, that is equal to, directly substitute it. That is 3 into 3 minus 3 by 3 plus 3. That is 0 into 0 by 9. Whatever it is, the answer is 0. How? 0 into something, again 0, irrespective of the new denominator. See here 3 plus 3, that is non-zero term. If it is a 0 term, it becomes an indeterminate form. Is it clear? Almost we have seen different varieties of questions in the first exercise. Clear? Shall we meet in the next session with a new exercise? Fine. Let us meet in the next session with a new exercise of limits. Thank you.